Well, welcome back, everyone. I finally got around to putting liquid metal on my Alienware X17, which has the 3080 and 11980 Intel chip that runs a bit hot, so liquid metal has a big impact. With liquid metal, less is more. You want to be careful. You don't want too much because if it can squeeze out and get elsewhere in the computer, it's really bad. So you want just enough so the surface tension on each side is. You'll see in these, I had a little too much first time around. These are what kind of my second and third takes when I feel comfortable with both the amount on the die and the top. I actually did a test run and connected the two and felt like this was just about right. So here I want to give you a little idea what I was dealing with before. This is what it would run both when I had it on the original Element 31 as well as with upgraded compound. As soon as I'd run anything stressful, even with an undervolt, it would instantly hammer to overheating. This was the fans cranked up or not. It was really bad, so clearly something needed to be improved, hence I'm doing the liquid metal. All right, so we have the liquid metal applied, and now I want to do a comparison from what I was originally with stock settings on the regular paste and now with liquid metal. So you see I'm setting the frequencies back and I'm setting the undervolt. I'm actually using throttle stop where before I was using Intel, and I was actually able to get a better undervolt with throttle stop, which I'm excited about. That seems to be a better software, and that's kind of what you read online. So we'll see me start up the Cinebench 23 run. You'll see here immediately it is absolutely fantastic temps. We're looking at 30 degrees cooler than before and actually maintaining that 45 multiplier on the frequency versus being throttled down to 41, what I was seeing before. This is all being done with the fans at full speed, sitting on my custom cooling pad at full speed. My house is a little bit cooler now, being that it's fall, but that doesn't translate into these huge drops in temperature. And when I originally got the laptop, I hit about 15,000, and that actually slowly deteriorated down to only getting about 14,000 when I was doing my final laptop comparison tests. When I opened it up, I saw that the Element 31 had thermal pumped out of between the die and the heat cooler and resulted in poor performance. When I repasted it, I got it back to about 14,500, but there was the risk that that was going to thermal pump out. And we see here I'm back at that 15,000. That's, I believe the computer was intended to run at without thermal limits, but obviously I was having issues with my thermal paste, and the liquid metal has gone a long way to improving that. So the liquid metal is doing an amazing job at keeping this cooler and is giving me a lot of thermal headroom, which made me ask the question, how far could I push this? How fast could I get those all-core multiplier up to? So this is going to wrap up running, and then we're going to jump in to see what it looks like in the different settings I was able to achieve using the liquid metal. As you can see, it finished up right in line with what the previous one is. It's nice and consistent with the liquid metal and the consistent cooling that we have going on with it. So you'll see here I am able to set the offset to about 100. I'm going to be increasing from that minimum of a 45 multiplier up to a 48 multiplier. As I increase that multiple, it needs more power, so I've got to use less of an undervolt, which I'm balancing between that undervolt and the power I can push. This has ended up being what a lot of my testing was, trying to find a balance between what I could put as my maximum frequency multiplier as well as trying to use my maximum undervolt without using so much of an undervolt that it was too much of an undervolt for the frequency. So it was a lot of a balancing act, because sometimes if I didn't use enough of an undervolt, I would thermal throttle, and so it was, and then I was getting a much lower frequency, but if I more went with a bigger of an undervolt, I was able to actually get a better frequency. So you'll see right here I'm topping out in the mid 80s I think when it finishes up running, but you'll see I'm sticking at that 48 multiplier that I wanted. It's rock steady. None of the cores are hitting the 95 to start thermal throttling. So this runs fantastic. I think I saw on the previous screen I'm getting to about 16,000. That was usually my consistent result without getting too bad. As soon as I started thermal throttling, but thermal throttle early, it just got worse and worse. So that would seem to be about the balance and one of the more consistent numbers I could run. To give you a feel for what the liquid metal does for the single core score, here you can see that wrapping up, and I was really impressed with that number. Last up here, I have what I would call my full blast Cinebench 23 run. This was shutting down all of the monitoring software and just letting it run by itself. I think it sat for a couple minutes to cool off, just to feel what the max score is. Some of these scenes have been resped just to fit the timing of the audio, but this one is running real time. And I would say that I would not run this very often because it was on its max settings. It's definitely thermal limiting. It's not hitting 95, but it's getting awfully close for this to run. I think it's running at about 4.9 for this one. And finishing up, you'll see the results here show that the liquid metal goes a long way to helping it. And this is a noticeably improvement over what I was sitting at after I had seen it deteriorate down to 14,000 with the stock paste. So clearly liquid metal has made a huge difference in the CPU, which is no surprise. This is something that gets really hot, and any ability to cool that allows it to run up to its max speed, and we're actually seeing this CPU getting close to its max potential with liquid metal, which is great. And there you'll see the max temperatures. We're getting pretty high up there, but it ran really well with these settings, so I was really excited. Great news, summer has somewhat returned, so the temperature in my house is back up to what is being limited by my air conditioner, which is set at 73 degrees Fahrenheit or 23 degrees Celsius for those who use a proper system. So here I'm just testing out just to make sure that I'm still looking good at kind of what I'd call my max setting, locking the cores in at a 48 multiplier, using the best undervolt, which is around 100 for that without issue. And we'll see once we get Cinebench up and running, the temps are in line. I wanted to actually use HW Info to get a good view of what the temps look like, because sometimes other software doesn't do a great job. And you'll see this really aligns with what the throttle stop was showing. So we see it's locking in at the 48 multiplier as well as sitting in the high 70s, low 80s. So it's running consistent even when it was a little cooler in my house, which I'm happy about. And we're going to see this finish up around 16,000, also consistent. Right after this video, I'm going to record it without the fans on full blast. I'm going to set it down to about 47, which will be my daily driver, and just kind of rerun this again, but with us being able to hear the sounds ramping up. And obviously it's going to be a little bit different because we're not starting with the fans at full blast, so it is going to heat up a little bit, but I want to get a feel for how long that takes. But we're going to have a lower overall frequency as well as a better undervolt to kind of see what it results in, and we'll see what it sounds like as well as it's ramping up. All right, here's the last one. I'm actually going to do it with the iPhone audio just so we can hear the fans. I've been doing all mine at full blast, but I'm not going to run it that way. That was just kind of comparisons. So quickly, have it set to performance on Alienware. Here's my settings. It's probably going to be my daily driver. I've upped my undervoltage. Then I have back down the cores here just to top it out at 47. And so I'm going to OK that and downsize that. And then to kind of take a look at the sound, what it sounds like ramping up, as well as the performance at probably my day-to-day there we go. Day-to-day driver kind of settings, and see where the thermals sit. So once this is up and running, that is fine. We'll see that it's warmed up a little bit. It always warms up with Alien Command Center open. I feel like that's a bit of a resource hog to have open. So we see that it heated up a little bit from before, but those temps slowly kind of come down as it's only doing other stuff. And I've ran Cinebench a couple times, so I've definitely put heat into the system since then. So I'm going to close this down. I'm going to close you. I'm going to go here and hit run. Here we go. So up and running. Oh, and it going. And we're going to go back to, I closed that. I thought I downsized my, I did not. I closed it. Oh, it's still running. There it is. So I'm this back up. Look at the temps. Topping at about 80C. We're at just below 4.7, what it sat at. So I think that's a real reasonable temp with the liquid metal. I'm not worried about it pumping out anywhere. And now we hear the fans kicking up because they're getting a little bit heat in them. But I mean, it was staying at its lower setting for a long time, and now it's like, hey, we got to kick up speed with this wrapping up. So it did a real good job of not needing that till right about now. Let's go and see. We still have that going, so we know the Cinebench isn't done, and now it's done as we see it drop. So let's go back to the Cinebench. Score finished up a little bit down. That makes sense though with the performance. Turned down a little bit. That's great. I mean, that's going to be a daily driver, and we see it's coming down in temp again because we have no draw on it, and those goes down and we quiet it back down. So I mean, we got a good long time there at the start with no sound, which I think is great. I mean, my tasks probably gonna be shorter than that versus editing some photos. So I think this is fantastic performance and temperature management. Now that we've beaten up the performance on the CPU, the next thing I wanted to look at was the GPU. GPU is different, and it doesn't benefit from liquid metal quite as much as CPU because it doesn't have such concentrated heat. While I was thermal throttling with the CPU with the original compound, the GPU was never thermal throttling. It was running toastier. It was definitely getting into the 80s and 90s when I was doing things, and the fans were definitely going like crazy. But obviously with the liquid metalling, it's going to help it cool better, as well as keep those fan speeds down and hopefully just make it a more enjoyable experience. To do an apples-to-apple comparison, I ran this first all stock without doing any modifications with MSI Afterburner, and you'll notice that this is running really quickly. I kind of gave this data so you can look at how the frequencies looked and the temps looked with a variety of things, but I have sped it up because there's quite a few of these. But originally, stock-wise, I was finishing around a 12,000 graphical score and a 11,000 CPU score. So we'll see the first one here when it runs clean. It was around 12,600, which is just fantastic. That is just a nice bump, even leaving it stock levels. But then I wanted to push it a little bit further. So with Afterburner, I kind of took two approaches to my overclocking. First, I started off mainly using just the curve, looking at some undervolting, using that to kind of get an undervolt while doing some other overclocking items. And I kept bumping that down at a lower and lower undervolting just to see how far I could push it. And when I wrapped up, I stopped around 13,000, which I was really excited about. And that's when I was kind of reaching the limit. So I dialed it down and got it nice, consistent results. No big deal. And so then I thought, okay, let's switch to the normal means of doing the overclocking. And that's where I put it to the standard. I think I finished up at maybe a 200, 300 overclock, and that's where it was nice and stable. It wasn't having any issues, and it was going repeatedly, so it felt good. And that's where I finished up with this final high score. So I'm really excited. I think these are great scores, especially starting out with around 12,000. This is a healthy little bump just by adding the liquid metal and turning the MSI on. I didn't do any of the MSI stuff beforehand. I kind of played with it a little bit when I was comparing laptops, but I didn't dig really far into it because I didn't want to compare silicon between those two. I kind of want to get a baseline stock out of the box, but here clearly temps are fantastic, even pushing it this little bit. The GPU is staying nice and cool, and that's just going to make gaming more enjoyable. I won't need the fan speeds all cranked up and going crazy. But here's a lot of data here. It's going to play out for a little bit. Watch what you want. And thanks again, everyone, for jumping on and watching. This is probably going to be one of the last videos I do on the X17 because I think I've used up all the material I can think of to do to this. Now I'm just going to enjoy it and move on to some other projects. So if you like what I'm doing here, next up is going to be a little bit of a couple of small woodworking projects, and then I'm going to get into my next PC build. So if you like PC builds, my next project, I'm trying to go a little bit bigger, a little bit better than my last one. So I'd love for you to subscribe and watch me as I go through that process and trying out my next adventure with building something. So thanks for all watching.